Hey, happy Friday, class. Sorry I'm here recording once again, but you guys have been troopers. I really appreciate it. I miss you guys so much, and I'm almost positive I'll be back on Monday. I still have a fever, but hopefully it's almost gone, and Mallory's definitely better. So please go ahead and write down tonight's homework. I'm going to try and get to as many of these problems with you as possible. Or you can just stop the recording and work on them together in class and get your homework done. So, totally up to you. Anyways, let's get started. I'm excited about this lesson because it's the easiest lesson in the whole chapter in my mind. It's straight probability. And so I'll be able to find the probability of independent and dependent events. I should know when to add probabilities and when to multiply probabilities. Straight probability is just like it sounds. It's straightforward. You don't have to worry about first finding out all the different possibilities, then divide that by the total possibilities. It's much easier than that. So hopefully you guys, it's a good one to have on a Friday, and it's a good one to have while I'm out. All right, multiplying and adding probability. So Gerardo has 9 dimes. So he has 9 dimes, and he has 7 pennies. 7 pennies in his pocket. He randomly selects one coin, looks at it, and replaces it. Now that's the key right there, guys. As soon as it says he reaches his hand in, grabs it, and puts it back in, that's when you know this is straight probability. Okay. He then randomly selects another coin. What is the probability that both of the coins he selects are dimes? So I want to know the probability of both dimes, which equals, there's 2 different things happening. Probability of him selecting a dime, and then, keyword here, and the probability of him selecting another dime. All right, so the probability of selecting a dime is there's 9 dimes in his pocket out of a total of 16 coins in his pocket. So the probability of him reaching in and grabbing a dime would be 9 dimes out of 16. The probability of him doing that again would be the same thing. 9 dimes out of 16. And the word "and," both things are occurring, means we have to multiply. If it was one or the other, then we'd be adding. So that's the only thing you really have to look for is the "and." Alright, so I put here a probability of A and B. These are event A and event B. So the event A was picking a dime, and event B was picking another dime. So you separate them and then find them. So when I multiply that, I get 81 over 256. Put that in the calculator, and there is a 31.6% chance of that occurring. Pretty straightforward, right? Okay, you guys go ahead and copy that down if you want. My suggestion, this is really straightforward probability. You don't want to write all this stuff out. Just I'm going to post it online, or it's already up there, so just print it out. Okay, 3 independent events. When 3 dice are rolled, what is the probability? First of all, how many sides are on a die? There are 6 sides. You've got a 1, a 2, a 3, a 4, a 5, and a 6. All right, when 3 dice are rolled, what is the probability that 2 dice, I'm going to start right now, the probability that 2 dice lost it. 2 dice show a 5, and the third is even. All right, so we've got to look at these all as separate events, right? So the probability, because each one of these die are separate events. So the probability of a 5 times the probability of a 5, because I've got one die as a 5, another die as a 5, sorry about that, and the third die is even. Well, how many even ones do we have? 1, 2, 3. Probability of even. Okay. So probability of getting a 5, well, there's only one 5 out of a total of 6 sides. So that probability is 1/6. Again, probability of a 5 is 1/6. Probability of even, like I said, there's 1, 2, 3 even sides. So that's 3 out of 6. Wow, I'm just not writing that well with this Moby today. 3 out of 6. Well, this one automatically, oh, I don't have a red up here. Let's get red. Alright, that becomes a 2. So 1 over 72 is approximately a 1.4% chance. So again, pretty straightforward. Okay, we're doing good on time. So go ahead and pause if you guys want to write that down. Otherwise, I'm just going to keep going. All right, 2 dependent events. So far we've been talking about independent events because rolling one die is independent from rolling another die. So let me show you how this one's a little bit different. The host of a game show draws chips from a bag to determine the prizes for which contestants will play. Of the 20 chips, let's start highlighting here. Of the 20 chips in the bag, 11 show computer and 8 show trip. So I'm going to go ahead and write that down. So there's a total of 20 chips and 11 show computer and 8 show trip and 1 shows truck. Gosh, I want to be in this drawing, right? So let's see, 1 shows truck. If the host draws the chips at random and does not replace them, so there's the key right there. They're not being replaced. Does not replace. Find the probability of drawing a computer then a truck. So that's what we want. Probability of a computer then a truck. Do you see why the order is already established for you on this one? Okay, so the probability of a computer, so the probability of a computer then probability of a truck. So the probability of the computer is, right here, 11 out of 20. 11 out of 20 chips. Then the probability of a truck is 1 out of 20, but we did not replace it. So the first one is he reaches his hand in and he pulls out a chip, and there's an 11 out of 20 chance that that chip is going to say it's going to be a computer chip. Get it? Computer chip? Ha ha ha. So anyways, so he takes the computer chip out and he leaves it on the counter before he goes and reaches back in the bag. So that means there's only 19 chips left. So if I want to find out if one of those chips is a truck, that would be a chance 1 out of 19 chance, because there's only 19 left. That's the important part about the then. first she pulls for the computer, we've got those chances. Now that one of the chips is left out, because that was one that we tried to get the computer. Now we're trying to get the truck. So I'm just going to go ahead and do the math for you. That's a 2.9% chance of these things happening. Not very big chance. Okay, write this down, or I'm just going to continue. All right, adding probabilities. So not much different. Like I said in the very beginning, multiplying is and, adding is or. It's one thing's happening or another. It's a lot harder for two things to occur. Two things to occur means you're multiplying, but if one or the other occurs, there's better chances of that. Okay, so Sylvia has a stack of playing cards consisting of 10 hearts. So I'm going to write 10 hearts, 8 spades, and 7 clubs. 7 clubs. So how many total does she have here? 25? 25 total cards. All right, if she selects a card at random from this stack, what is the probability that it is a heart, probability of a heart, or a club? So let's see, probability of a heart. The or means plus, probability of a club. So the probability of a heart, well, there are 10 hearts out of 25 cards. Plus, probability of a club, there are 7 clubs out of 25. Now, if it was, what's the probability that it's a heart or a club? If it said probability of pulling a heart and then pulling, well, I guess that wouldn't matter because the and would make it multiplication anyways. I was going to say the whole replacement thing. But it's one thing's happening or another thing's happening. So sorry to take that sidetrack. Okay, so 10, they both have a common denominator, so it's just going to be 17 out of 25. So there is a 68% chance that we're going to pull a heart or a club. So a great chance. All right, I'm going to move on. All right, 3 mutually exclusive events. Okay, so I'm looking at this one, and I don't think this one is a combination probability problem, and I don't want to throw that wrench in there, so I'm going to look at your homework and make sure that I haven't assigned anything that has this. I just want you guys doing straight probability. Okay, so I stopped the video and I did all your homework problems and decided to cut them way down to make sure that this was just straight probability. So I changed it to 13 to 27 odd. I forget what it was before. And then in the second part, 1 through 7 odd and 27 and 29. And I'm going to do at least 3 of those homework problems with you. So let's go finish the last one. So we're not going to do this one. We're going to do this one. Okay. So there are 2,400 subscribers to an internet service. I'm going to say 2,400. Of these, 1,200 own brand A. So say 1,200. And of these 1,200 own brand A, 500 own brand B. 500. And 100 own both. What is the probability that a subscriber selected at random owns either brand A, so probability of A, or B, which would be the probability of A plus the probability of B, but we have to subtract the probability of both. So the probability of A would be 1,200 out of 2,400. The probability of B would be 500 out of 2,400. But then we have to subtract the ones that have both, which would be 100 out of 2,400. So we call this an inclusive event because it involves where there's some overlap. This is pretty straightforward. So 1,200 plus 500 minus 100 is 1,600 over 2,400. Cancel those zeros. And I just have 16 over 24, which is 2/3, or 66.6%. Okay, so that's all I'm going to show you that's new material. And now let's do 3 of your homework problems. Let's see, these are answers from yesterday. Oh, that reminds me. So these are fair games. I want to see these on Monday. So I want to see Thursday night's homework and Friday night's homework on Monday. You should have been able to do these pretty easily. These were harder. I want to show you how to do this on Monday. I did all the homework. Everything I've been assigning you, I've been doing at home to make sure that I'm right on page with you. And these were more difficult. I need to give you guys some more instruction on this. Or maybe talk to Easton on a way to approach this easier, because it's just not fun stuff. Okay, these are fair game from your homework. So basically, I'm just 16 through 21. Don't worry about those. And I didn't even make you do these, so don't worry about that. All right, so, ooh, we're going to have a problem because I've got other homework from last year in here. So out of the ones that I did, let's do 13 together. So a die is rolled twice. Find the probability that there are no 6s. So the first time, probability of no 6s would be probability of no 6, and probability of another no 6. Well, if you have 1, 2, 3, 4, 5, 6, well, if it's no 6 both times that you have a die rolled, then it would be, there's 5 out of 6 chances times 5 out of 6 chances equals 25 out of 36. And in your book, it's all going to be in fractions, so you need to put it into decimals. All right, the next one I'd like to do with you is number 5 on the next homework page, which I don't believe I have. I don't. I'm going to pause the video and go grab it. Okay, so I've copy and pasted this. So let's try and do number 5 on the second page. Okay. So a die is rolled, find each probability. So a multiple of 3 or 4. So that's a probability of a multiple of or the probability of a multiple of 4. Alright, so on a die, 1, 2, 3, 4, 5, 6, we have to ask ourselves, do this in 2 different colors. A multiple of 3 is going to have red checks. So is 1 a multiple of 3? No. 2? No. 3? Yes. 4? No. 5? No. 6? Yes. And a multiple of 4, I'm going to do in green. So 1, no, 2, yes, 4, yes, 5, no. So both of them have 2 options. So this would be 2 out of 6 plus 2 out of 6, which is 4 out of 6, which is 2/3. Okay, last one I'm going to do. I'm going to do 27, and you guys can do 29. Alright, so here's 27. 2 cards are drawn from a standard deck of cards. First of all, a standard deck of cards has 52 cards. And it's got 13 in each suit. Of each one of these, 3 of them are face cards. And I double checked, an ace is not considered a face card. So just a jack, a king, and queen. Alright, so we need a probability of both jacks or both face cards. So first let's talk about probability of both jacks. So probability of both jacks plus, because I have an or, the probability of both face, but then I have to subtract the probability of any card that is both a jack and a face, which probability of both. Alright, so let's talk about this. This in itself is its own probability, because both jacks is the probability of pulling a jack and pulling a jack. So the probability of a jack and a jack plus the probability of a face and another face minus the probability of both and both, because we're pulling 2 cards. 2 cards or another 2 cards. So the probability of pulling a jack would be, there are 4 jacks. There's 1 in each one of these suits. If this is hearts, spades, clubs, diamonds. So each one of these suits has a jack. That would be 4 out of 52. And multiply another jack. Well, I already picked 1. So there's 3 out of 51 left. That's like its own event right there. Or we could pick a face. How many face cards are there? There's 3 face cards in each. So that would be 12 out of 52. And then if I picked another one, I've already picked 1, so it would be 11 out of 51. And then we've got to subtract possibility of both. So probability of both, well, how many cards are both a jack and a face? Well, every jack is a face. So in each suit, you've got a card that's both a jack and a face. So that would be 4 cards out of 52 times 3 out of 51. And notice this one's nice and easy because 4 times 3, this right here, if I were to subtract this, look, they're the same thing. So if I have it and then I subtract it, I don't even need either one of them. So really all I need is right here. This is it right here. Okay, so I know that 12 is 3 times 4. I know that 4 divided by 52 is 13. And 3 goes into 51 17 times. So I have nothing in the numerator here except for an 11. My answer is 11. And 13 times 17 is 221. There's my answer. So you guys try and do 29 based on this one that I did for you. So I think you only have left maybe, I don't know, 12 homework problems, maybe even less than that. I'd have to go back and look. All right, guys, have a great weekend.